So here's what we've got. Yesterday we talked about this trig ID. Cosine squared plus sine squared equals 1. The reason that that works is because of the Pythagorean theorem. When you're on the unit circle, when your theta value is placed there, if you're just quadrant 1, your adjacent is your x value. Your vertical, or your opposite, is your y value. Your radius is here. The radius of the unit circle is, bless you, is always going to be 1, bless you. So if you look at it in terms of what x and y stand for, your x value is always your cosine, your y value is your sine. That's why we can say that cosine squared plus sine squared is 1. That's where all that comes from. As we get into it more and more, after we get back from break with some of the other identities, there are other identities that work with tangents and secants and cotangents and cosecants as well. That's later on, but we're going to be doing a lot of that work later. So by knowing that this works, you can manipulate cosine squared x plus sine squared x to get either one of them by themselves, just by subtracting the other unit out. So here is my biggest thing that you should look for. When you have a squared term of sine or cosine, and the other term is just is the opposite without being squared. So if it's a cosine squared with a sine, or it's a sine squared with a cosine, you always want to rewrite the equation in terms of the one that has the degree of 1. Okay. That way you can factor it. So what I'm going to do here is rewrite this equation in terms of everything being sines. To do that, I know then that cosine squared x is equal to 1 minus sine squared x. And all I did was just manipulate the equation. Okay. I solved what we call a literal equation, and then I'm going to use substitution. Bless you. Use substitution to put it all back together. So now I rewrite it as 2 times the quantity 1 minus sine squared x minus sine of x minus 1 is 0. Okay? Distribute. Excuse me. When I distribute here, I'm going to get 2 minus 2 sine squared x minus sine x minus 1 is 0. Okay, okie dokie? I don't want to try to factor any of this stuff with a negative first term. That's just asking for trouble. So I'm going to move everything to the other side. As I move things to the other side, I'm just going to combine my 2 minus 1 and know that it's a positive 1. So when I move it, it becomes negative. Are we okay with that? So I'm going to get this. 2 sine squared x plus sine x, and then it would be plus 1, so it would be minus 1 on the other side. Yesterday I showed you guys a little trick about what's called U substitution. That U substitution is great for when things look like crap, that you can make it look nicer. You don't need to use it, but in times that if you have like a 4th degree and a 2nd degree, it's a lot easier. But if something's just squared, it's a regular old trinomial, you can kind of get away without using it. Do you want me to show you again with the U step or not? Well, if we don't, what's 2 times negative 1? What times what's negative 2 that you add together to get positive 1? 2 negative 1. So we get 2 sine squared x minus sine squared, or minus sine of x plus 2 sine x minus 1 is 0. And this would be the same as 2u squared minus u plus 2u minus 1. It's the same thing.
Not looking at it, it's like a regular algebra problem, just because like the sign and like just like throws.
And that's why I say, use that. And make something that looks like crap easier to read. That's all. It's a great trick. You use it a ton.
So like you're saying, like if you have like a sine and if you have a cosine, then just use like u represents cosine, or like.
When I have squared terms, if I have a trinomial, if I have a trigonometric trinomial, I might use the u step because it's just cleaner, and that's all. So now I just factor via grouping, which I know we all know how to do. what do these two guys have in common? They have a sign. So we factor out the sign. We move this up. And the other one has a 1.
I keep on saying it says 25 inches square. Do you see what I mean?
I see what you're saying,
Like,
yes.
especially in the one on the right. The one on the right is so.
Do the two things in parentheses, are they the same? Yeah. That means that was we factored it out correctly. So we have 2 sine x minus 1 equals 0. And the other one's going to be sine of x plus 1 equals 0. So we set our two things equal to 0 like you would before. So what angle has a sine value of 1/2? This is the first one. Do I have to show all my work to you guys about what I did there? I'm assuming we can add 1, divide by 2, and rewrite, and we'll be okay. So sine being positive, that's automatically going to be my first quadrant. It's also going to be my second quadrant. So what angle has an opposite of 1 with a hypotenuse of 2? 30, very good. So that's going to be my pi over 6. In quadrant 2, reference angle of pi over 6 makes me pi over 6, very good. I will come back in a second to talk about general solution after I solve the other one. The other one is subtract 1. What angle has a sine of -1? So that means it's going to be, where is your y value? -1. My y value is going to be -1 at 270. Okay? -1 at 270, which is 3 pi over 2. Yes, sir.
How can it be negative if the x isn't the x value -1?
No. What angle? What that says is what angle has a sine of -1? Where is sine equal to -1? At 3 pi over 2. If I took the sine of 3 pi over 2, it equals -1. That's what that means. Okay. Between pi over 6, 5 pi over 6, there's no common differences, so your general solution would be pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, and then this one, obviously, it's just going to be 3 pi over 2 plus 2 pi n. That should keep going around. And remember, all this 2 pi n stuff is just it's just compensating for every single other one that'll have that same reference angle. Yeah, try.
No, don't you have like the 7 pi over 6 and a 11 pi over 6?
It's positive. 7 pi over 6 and 11 pi over 6 sine is negative.
And how do we get that yesterday?
Because you took a square root over an equal sign, you got plus minus.
Oh, okay.
That's where all that comes back. If you got to watch your signs, you're outside genes. What do you got?
No, like, it would make sense, but it goes to sine, not cosine, so now I'm confused. Does it end up being another one of those big factor problems?
No, actually.
Really?
This one's actually easier. What do you have?
I was just gonna say for the 30 of the 1/2 that we used, we knew that it was positive in only the second quadrant because of like the all students thing, because it was the sine of 1/2. So we know that it's in the first quadrant, and then the first quadrant is like all students.
Yep. And remember,
I get nervous that I'm not gonna know how many quadrants it's in, unless it's like plus or minus.
then write it as plus. If you know plus or minus, if you know, how about this? You know x and y are both positive. X is negative, y is positive. Negative, negative, positive, negative. You know that, right?
Yeah.
Then just draw that on your piece of paper. Remember, as soon as you sit down with it, that way you don't have to remember all students take calculus.
Well, I remember all students take calculus, but I feel like there's so much more.
Well, the problem is that sometimes you guys don't remember if that's positive or negative. So if you write down your ordered pairs for each of the
Because
4 quadrants.
if it's cosine and it's negative, because the cosine, so that would mean that it's in the second quadrant and the third quadrant?
Yep.
Because cosine is cosine.
Right.
Oh.
Gee, that whole alphabet thing comes back together, doesn't it? It's convenient how I tried to make sure you guys understood that. Okay. So you have cosine x, cosecant squared x, plus 3 cosine x equals 7 cosine x. In other words, a whole bunch of fun.
You can just combine all those things.
Well, first thing you have to do is set one side equal to 0, which means I'm going to move the 7 cosine x by subtraction. So in doing so, I get this. Cosine x cosecant squared x minus 4 cosine x equals 0. Bless you. What's your first rule of factoring? What's your GCF? Cosine. Factor out a cosine. So you get cosine x times cosecant squared x minus 4 is 0. Do I now have, now you're back because it was that easy. Now you've got 2 terms that you can set equal to 0. Set them both equal to 0. You didn't have to do any craziness here. Cosine of x equals 0, and then cosecant squared x minus 4 is 0.
So then it's plus or minus 2.
Correct. So this one is, what angle has a cosine value of 0? In other words, where is your x coordinate 0 on the unit circle? Well, your x coordinate 0 at 90 and 270, so pi over 2, 3 pi over 2. This one's pretty quick. What's the general solution if it's at pi over 2 and 3 pi over 2?
Pi, pi.
Yeah, so it's just be pi over 2 plus pi n, because then you just go here, then you get to here, and you go to here, and you get to here, and you go to here, and you get to here, and you go to here, and you get to here.
Are we learning more stuff? Are we practicing?
I'm just trying to make sure you see, wait. Yes, I'm going,
And then you were going
but
like.
my hands don't move that way.
You need more hands then. There you go.
I can try not to.
I'm going the right way, aren't I?
Now you are.
Yeah,
No,
but you were
no.
going like, you went this way. So you were going this way and then you went down. Stop.
Is that right?
I don't know.
I'm trying to do it towards your. Well, that was really stupid. You didn't see me just do that. It happens to everybody. So this one you're going to get cosecant of x is going to equal plus or minus 2. Add 4, take the square root. Now, cosecant is the inverse of which trig function? Sine. So that means that I'm looking for something that has the opposite is of 1 and a hypotenuse of 2. So I'm looking at a 2 over 1.
So you're looking at a 30.
I'm looking at a 30. I'm looking at pi over 6 again. I'm looking at pi over 6, and as you pointed out earlier, Emma, it's the bow tie of pi over 6 because it's in all 4 quadrants. That's good. Why do you guys hate me?
She's just like.
She's very hard to impress. And then the other one would be 5 pi over 6. And as you get into a lot of, hopefully you've noticed, there's only so many angles you can wind up with. So you just kind of have to.
Like it only seems really good, and you try to look back at it, you're like, I don't know.
It gets very hieroglyphic-y. Perfect. Hieroglyphic? Glyphic. So it gets very hieroglyphic-y.
I don't think that's a word.
It's not a word. I just made it up, but it sounds good. So far, so good? Yes, sir.
That's the past
Help yourself, man. Yeah, you guys I want you guys to make sure you got caught up by the time we get to Friday, so you guys can, don't have to worry about over break. Let's do some more.
We're just practicing this today, right, Mr. Murphy?
Good chance. I don't need
Less.
No, this is kind of the end of where I want to be at right now. I thought about trying to get into, I wanted to talk, I thought about getting into the intersection of these things because we can actually do the intersections of where these two wind up to each other, but it might just be, with time and stuff and how messy some of these things can be, I don't think I counted right, so I don't. Math is ready to go. There are some that are on here that you do not know how to do, nor am I going to ask that you know how to do this quite yet. We will probably come back and revisit some of these problems later after we learn about our trig identities. So, excuse me. Let's cross off on the A side. We're gonna do a no 1, 6, and 13.
Just take out one and do.
But you should be able to do the rest of them. I'm not worried about the 19 through 22 because that gets into the graphing portions and the intervals and solving the systems. I'm not worried about any of those. So the rest of them, that 1 through 18, you should be good. Except you don't have those 3 you don't know how to do. I'm not going to bother with those 3. On the B, you should be happy at numbers 1 through 12. Should be happy. And I don't believe. Yeah, everything on there you're going to be able to do. There's nothing that has another identity that won't work. Everything else works fine, okay? As you also look at it, it says solve general and then solve interval. Remember, interval's the easier of the two, it's just list out all the angles, whereas general, you're trying to make it very, very simple. What I'd like to do with you guys real quick is walk you through how I would do 5 on the B, okay? I'm going to walk you through how I would do 5 on the B. And that's one of those, it's cotangent to the 4th power. Oh, wait, we did that one yesterday.
Yeah.
Never mind.
We should walk us through again.
Let's do 9. Let's do 9 on that side then. That one looks ugly.
Can you just
I didn't realize we had to do this on extra paper.
Yeah, I don't even know why I closed my
So there's just kind of ugly. So it's kind of ugly, just, a smidge.
just a little bit.
After we write down this monstrosity, what do you think the first thing you would do?
Subtract the 3 cosine.
Or would you subtract anything else to the others?
You know what? I originally I would say move the 3 over to the left, but then when I looked at it, I said, oh, that would give me a negative, and then I have minus the next chunk. So I would take everything from the left and go to the right in this case. Okay, I'd move everything from left to right. So I will get 0 equals cosecant x plus root 2, cosine cosecant x. It's weird with the 0 on that side, I don't like that. Whew. I feel better now. I think it's because I'm right-handed. I want to work towards that. What do I do now? factor the cosecant. Remember when I said you guys are gonna have to do factor with trig? I wasn't lying, was I? I don't lie to you guys, believe it or not. Like, I remember the whole imaginary trig?
No.
You'll have that next year.
That's all it is. That's all it is.
Yes, I get it. There's a lot of Murphyisms that I say. That's one of them. That's all.
That's all it is, guys.
I'm trying to be
It's really
supportive.
not bad. We're just,
I get it. It's like the, I don't know, 5-6 years ago, one of Fontana's classes decided to count his claps. I think I told you that, right? Right, he does a lot of, he's a clapper, so they tally mark the claps.
that's funny.
See.
And you know Miss Johnson?
Yes.
No, not that Miss Johnson. Miss Johnson from Rosette Devin Johnson's mom.
Yes,
That
yeah.
Nikki Johnson.
Yep. Yes, I had both the Johnson
This
girls.
one kid tallied how many times she laughed at her own jokes.
That would be something you guys would tune in me, because
What?
That's funny.
That was Bobo.
I get like a stopwatch out and they record how long she looks at the floor. Like, I remember how she
Miss Johnson?
yeah. Like, they'll, like,
I
send it-
loved
like she'll
her.
look down and they'll
She's
start.
great. She's
She
such,
talks to
she's
the
a
floor.
really nice, very nice.
I loved her so much. The he was the best.
All right, so I have cosecant of x equals 0, which means, excuse me, it's the inverse of sine. And then the other one's going to be what angle? This could be cosine. What's that? No, because think of it as 2 times cosine of x. If it's just root 2 times cosine x, undo multiplying, you just divide. I'm not squaring anything. Okay? And it's kind of a common thing that people try to do. So, cosecant, what angle? So it's the inverse of sine. So this, what? Can you take the inverse of that to make it work? Hold on a second. When you get going into this, as you go through the unit circle, you have zeros for sine here and here, right? Because that's 1, 0, and -1 and 0. If cosecant is the inverse of sine, it becomes 1 over 0 then, right? So that's an undefined, right? Isn't it? Cosecant can't equal 0. It's undefined. Because what I want you to think of is cosecant is the inverse of sine. Sine is your y value. So what you want to do is you look at, well, where's my y value? 0. 0, it's 0 at 0. But the inverse of that would be 1 over 0, which means it's undefined. Correct. This is undefined. Okay. This is undefined. Now, this will actually make a little bit more sense as we start talking. We actually really get into the graph.
Would that mean that that secant would be undefined too?
It could be. Secant could be undefined then at what is it? Pi over 2 or 3 pi over 2.
Yeah, because if it was like, if it was secant of 0, that would also be undefined because it would be 0 over 1, right?
Correct. What's the maximum and minimum value for sine? 1 and -1. If you start at the unit circle, sine starts at 0. At pi over 2, sine becomes 1. At pi, sine is 0 again. At 3 pi over 2, sine becomes -1. and then back at 2 pi, it's back to 0. Everybody okay with that? So your standard oscillation then, well, your standard look of what a sine curve would do as it goes around the unit circle, it's making that wave. Now, when you do inverses of things, all you're doing is you're flipping the values. For example, what's the inverse of 1? 1, not reciprocal. What's the inverse of a half? 2. Inverse of a half is 2. Inverse of 0 is undefined. Inverse of negative half is negative 2. Inverse of negative half is negative 2. Inverse of negative 1 is negative 1. Inverse of 0 is undefined. So what's happening is, as you take the inverse of all of the values of sine, it creates a cosecant graph. The cosecant graph is the sine graph blown up. And it creates its own asymptotes at zeros because the inverse of 0 is 1 over 0. That's why it's an undefined function. I probably won't put anything that has a cosecant or a secant of an undefined function on the quiz for you guys because we haven't really gotten into too much of this yet. I've only kind of shown you. I haven't done all the other stuff yet. All right. It's just that's how it works. But then cosine of negative 1 over 2, that means your cosine value are going to be in second and third quadrant. That means I'm looking at the negative, or my negative 1 is my adjacent, my root 2 is my hypotenuse, which means it's got to be a
60. What? 45,
45. Yeah. So going into the second quadrant, that means it's 3 pi over 4. And then third quadrant would be and from there. Okay. The rest of them are okay.
Where was
Okay?
the general part of that?
That was in an interval. That was on the intervals. Just list them. If it was general, it would have been 3 pi over 4 plus 2 pi n, 5 pi over 4 plus 2 pi n. The other one is an undefined function. You can't do it. I don't think there's anything else that has undefined. Because that would be cosecant. Cosecant is 0. Yeah, number 8 you'll have an undefined again because you might have put cosecant equal to 0. Yeah, try and get through all those and see what we can come up with. We'll review a few of these things again tomorrow. My idea for the Quizam is 13.2, 13.3, 13.4, and 14.4. If you guys recall, 13.2, 13.3 was all about reference angles. What is a reference angle? What is the sine of 7 pi over 4? Things like that. You know, what do you get when you spin something around? What are the x coordinates, the y coordinates, things like as you go through it. 13.4, same idea. You were just kind of spinning things into the quadrants to figure out where things were at. And we just used all of that in 14.4. I'm sorry, 13.4 was what angle has. So that was the inverse sine of 1/2. You know, what angle has a sine of 1/2, that kind of stuff. And then we just used that in the 14.4. Pretty sure the way I'm looking at it is going to be all non-calculator and going from there. And then Friday, pi down. I came up with some rules. For 20 digits, you get 2 points.
Oh my god.
Every 15 points, or every 15 digits after that is 1 more point. The winner per class period, so that it's fair to everybody, the winner per class period gets 5 bonus. Second place is 3, third place would be 2. I'm thinking that it's going to be the easiest way to do this is if we write it out and just go from there. And that way we can go. The bonus points would be put into the quiz category. So it's like a homework and a half. As you get, it's like a free homework and a half is what it works out. Okay. Does that seem fair enough? Because I kind of put it up at 20 digits. I mean, you guys, it's 2 phone numbers. Do you know 2 phone numbers?
That's it. We don't remember it.
If you remember 2 phone numbers,
Wait, so you're talking about memorize a side?
What's that?
What's the phone?
Yeah, but if you memorize two phone numbers, those are two 10-digit numbers. That's two phone numbers.
We have to memorize pi by line.
Right. Try and keep
Isn't
up.
like
Wait, how many do you need to get 5 extra credit points?
0. It's on the wall. Were you just listening to anything I just said?
Honestly, I thought that you're talking about something completely different. All I heard was bonus, pi down.
What is a
5
bonus?
credit
For pi
points,
down.
Quiz category, that's all I heard. 20 digits?
How many are there?
there's
I know 3.141592.
265.
5, 6.
3, 1.
Oh, that's what you mean by pi.
Oh. Pi is fun.
Yeah.
I'm close to 20.
What's that?
I'm close to 20.
Nice.
Wait, did the 3.1 work out pi?
The